Hey, this is Barnaby reviewing today's starter. So part A says find the molarity. So you need to know the equation. It's moles of solute over liters of solution. So take the grams given to you in the problem, convert to moles using the number on the periodic table for molar mass. Divide by the liters of solution. You get 0.51 moles per liter NaCl. You can write 0.51 big M, but I like to show both units. It's helpful sometimes in problems to for showing how the units cancel out and giving you another check that you're doing it right. Part B is the dilution. That's where you have a certain amount of chemical in something. So you have a certain number of moles, but then usually you add water. So the moles don't change. So that's why the steps are find moles and then divide by the new volume to get the new concentration. So the moles, just like the work from the previous problem, are 0.051 moles of NaCl. Our new volume is 0.1 liters plus 0.1 liters, so it's 0.2000 liters. So moles divided by total solution volume. I added the word total here because some problems won't give you the total. They'll say you have 100 milliliters, then you add 100 milliliters. So you need to know to divide by the total volume that it's in. So you get 0.26 moles per liter. Notice that the concentration went down by a factor of 2 because the volume went up by a factor of 2. For the other one, we can find moles by using molarity times liters is moles, and then divide by the total volume, we get 0.12. Okay, there's an easier way to do dilutions. Please do not use this equation I'm about to say for titration problems. A lot of things on the internet say use this equation for titration problems. It does not work for all titration problems. Equation for dilutions is the molarity times volume, that's moles first, equals molarity times volumes, that's moles second, because the moles don't change when you add water for a dilution. So for example, the second part, we could do molarity times volume equals new molarity that we're solving for times new volume, the total volume. And notice that the units work out fine without converting to liters and things like that. They would have in the previous problem too if we'd wanted to. And so you get the same answer. Okay, part C. Here are your reactants. Asks you to find a precipitate and write the balanced equation. So we check the combinations. Sodium with nitrate is a possibility because it's positive ion with negative ion, but alkali metals are always soluble and nitrates are always soluble, so no precipitate there. So it has to be the other one. We also have a solubility rule that says chlorides are soluble except silver, mercury, and lead. So yes, lead, the positive metal, with chloride, the negative ion, is going to make a precipitate. So we write it over here. Lead is +2. You can tell because over here it's with 2 nitrates, which are each -1. So lead is 2 over here. Chloride is, you say chloride when it's an ion, and chlorine if it's Cl2, no charge. So this is definitely chloride. Is -1 because it's in group 17, so we need 2 of them to balance out the positive 2 charge. So that's our solid. And then the leftovers are sodium and nitrate, +1 and -1, balance the equation. So there's 2 nitrates here, so I need to put a coefficient 2 to make it 2 nitrates here, and that makes 2 sodium, so I put a coefficient 2, and that also takes care of the chloride. Okay, this is easy or hard problem depending on how your brain works, basically. You don't actually have to do math. It's just usually the way this shows up on a test is actually giving you a drawing. I won't have you draw stuff on tests, and AP tests won't either. But they'll give you a drawing and say like which drawing represents what the result is when you mix these 2 solutions. So you can think through it. I tried to think through it with words first. We have 200 milliliters total. It contains 0.12 molar lead-2 nitrate and 0.26 molar sodium chloride that will react. So if I look at my balanced equation, I should have 2 moles of NaCl for every 1 mole of PbNO32 from the coefficients. And I can just compare molarity since they're in the same solution, in the same volume. I hear Timmy. Timmy needs to play with me, so I'm almost done. So I should have double the amount of NaCl, and I have more than double the amount of NaCl. If it was double, I'd have 0.24, I have 0.26. That means that NaCl is the excess reactant, which means lead 2 nitrate is the limiting reactant. So then I was thinking, oh, so there's no lead 2 nitrate left. That's not really true, because the nitrate doesn't actually react. It's just hanging around there. My equation here, the complete equation, is kind of misleading. It looks like it turns into something else, but really nitrate here is aqueous, nitrate here is aqueous, it doesn't change. So I thought, okay, maybe I can see that better if I write the net ionic equation, or complete ionic equation rather. So the lead is going to be gone. It's the part that reacts in the limiting reactant. The nitrate's all going to be left, it's not doing anything. The sodium's all going to be left. Some of the chloride is going to get used up to make the lead 2 chloride. So maybe pause the video and look at that equation and see if that makes sense to you. But here's the other way to do it, is you would write out the net ionic equation. So the ones that are aqueous, write them out as ions because they are ions, And then you can see this is the part of the limiting reactant that gets all used up. This one's not used at all, so it'll stay 0.26 molar. This one's not used at all, so it'll say 0.24 molar. Some of that'll get used up. It's kind of tricky to think through how much is left. Here's the limiting reactant, so I just started with that. It's okay if this part doesn't make sense. But all of that gets used up, which means double that amount of this will get used up because of the coefficient. So then I drew a picture. If you can match up the picture, then you would be fine on a test. So I drew more water than sodium, and more sodium than nitrate, and more nitrate than chloride. And there's no concentration of PbCl2, that's just a solid sitting at the bottom. So that's a common thing in multiple choice problems that tricks people, is it asks you to choose a concentration of PbCl2. There's no concentration because it's solid. Hope that helped.